Hello and welcome back to my channel. Today we are going to talk about different kinds of joins provided by Snowflake. So we are going to understand how those joins behaves and how they can be implemented in Snowflake. So this explanation will help you how we can use these kind of joins in which specific scenarios, because there are going to be multiple data sources, multiple data sets, and you have to create new data pipelines on top of them. So you might have to join couple of tables or maybe multiple tables also. So there are multiple joins can also be used. So that will help you in your career. So please stay tuned till the end of this video. So you will understand all kind of joins. So let's get started. So here is the screen where you can see there are basic joins are available in Snowflake as well, similar to other SQL languages like inner join and outer join. So inner join is always a default join in most of the languages, most of the database technologies. Even for Snowflake also it is the same. So what happens when you use this join like normal, and if you can write also like this inner join. Okay, so when you do that, what happens is that it will try to match all the rows from employees table to this departments table based on given condition. So whatever records are matched on the both the side, only those records will be returned. Let me show you first what are the employees looks like and what are the departments looks like in the table. So here as you can see, I have already executed this one and I got the records here available. So but before that you can, okay, let me run this. So here is the departments. So there are 4 departments are created and I have recorded here. So you can always map with this result. So you can understand what happened. Okay. These 2 lines we will execute when I'll be able to explain them further. Then this is the employees. Okay. Let me show you. We have 7 employees. And out of 7 employees, all have the department ID, as you can see here, right? So one department ID, as you can see here, is the 4, which is not available in this database, in this department section. So we will see what happens when you use the different joins. So these are the data. Now let's go and hit this first inner join. So when you hit the inner join, as you can see, we got only 6 records. Why? Because 7th record was not matched, as department ID is 4 and we do not have any department with that ID. And as you can see, this operation is also having 6 ID, which is also not assigned to any employee, and that record also did not come from the departments table. Now what happens if I use or create one record like this with the same ID? As you can see, we already had engineering with the ID 1, but now I created HR department with the same ID 1. Okay, now if you run the same query, what will happen is that it will create duplicate rows associated with the same IDs. So as you can see here, this arrow pattern has department ID 1. So it created 2 rows for Arav Patel with the 2 different departments, because we have 2 departments with the same ID. So you will see duplicate records. Okay, now let me remove that. Okay, now again we have only this 4 records, and let me go to the outer join. So second join is outer join. In outer join you can always use 2 joins, left, right, and third one is full outer joins. So in left join, what happens is that left, that means there is employees which you have done in the from statement, and then you are writing a left outer join. You can always ignore outer word, that keyword is not required, because when you write left, it automatically considers the outer join. Okay. So left outer join, and there is the right table, right side tables, that is departments. So in that case, whatever records are matching from employees to departments, they will always come. But whatever employees are having department ID which is not existing in departments, still the employee will come as part of the result. For example, we have, let me show you, we have this employee, this 7th Makal Patel, which has department ID is 4, right? But as you can see, there is no department with that ID. That means this record will also come if you use left outer join. But for this column ID and name, the values will be null. So let's run this command and you will understand based on the result. So now as you can see, we got all 7 employees from the employees table. So now whether right side, whether department exists or not, you will always get the employees with whatever filter conditions you have provided. So that is going to be helpful. Okay. So now the same way you can use right outer join. So what happens in right outer join? You can assume it, right, based on this left outer join. Now right side tables records will come all, but from the left side, whatever records are not matching in both the table, they will not come, like this Makal Patel. So Makal Patel record will not come as part of the right outer join result because this is not matching from on the right side table department. So now what happens with this operation department? Because there is no employee exist for this department ID 6, right? So still this record will come with the all columns with value null for these employees columns. Let me run and let me show you that. So as you can see, there are 6 employees which are having matching department ID, and that's where we have got all 6 records. But there is 7th record which has operation department and all the values are null for employees, right? So that's how right outer join use. Now if you use full outer join, then you will get all 7 employees and all 4 departments as well. But you can clearly see how it works based on result. So you will see 8 records will come because Makal Patel has no department associated with it in departments table, and the same way for 6 department there is no employee associated with it. Because of that we are getting nulls in all the columns and here also. So that way you will get universal record from both the tables. So this is going to be helpful in some cases. So you will also get idea when you are going to work on any data engineering job. Now there is a cross join. So cross join doesn't have any condition, because cross joins means it will try to create all the combinations possible from both the table. So as you can see, we have 7 records here and 4 records in the right side table. So it will create 7 multiplied by 4, 28 records. Let me run it and you will see. So as you can see, you got 28 records because 7. So each employee will come with 4 departments. Look at this. It has department ID is 2. Still it is created 4 records for all 4 departments. So it is giving you cross join. Okay. So make sure whenever you are using any table, don't use cross join without any requirement, because cross join is going to cost a lot. Because if you are working on million records and there is another table which kind of having also million records, then million multiplied by million, it is going to be a large number, and that might chalk up your memory usage of the compute resources, and then you can exhaust the cost limit. Okay, so make sure that always be cautious while using cross join. Now there is another join provided by Snowflake is natural join. So when you use natural join, again similar to this cross join, you do not need to provide on condition, because in natural join Snowflake tries to find out what are the similar columns, not similar, same columns, I mean columns with the same name, right? So in our case, employees has ID and department also has the ID. Even though they do not have relation right now in our case, but in some cases you might have relation between those 2 tables with the same ID. Like suppose you are having one UUID column, right? Department ID, and you have order table, okay, employees table, and then orders table, and in both the cases department ID is there. And now we want to join order and employees, department ID will be common, right? So it will automatically take that DEP underscore ID because name is same. So it will try to join with that column. So that condition will be automatically added. So now in our case, you know that, right? ID is the common column in both the cases in employee and table, in employee and department. So let me run this natural join, and you will see only 4 records we got because only have 4 rows here which are matching with this ID, and ultimately it is taking inner join, and you see the IDs are matched. We have, let me show you, 1 2 3 up to 7, right? But here if you see 1 2 3 and 6, because in departments we also have 1 2 3 and 6, right? So that is why we are not getting that. Okay, now there is another way of implementing join, is that you can directly give 2 tables in the from statement, and you get the and you give that condition joining them using where. So this also give you the same result, but it will ultimately a inner join. It will not be a left join or right join, but it is inner join. So you can implement this way as well. So another tip, like when you use multiple joins, so make sure that joins are in order, so performance might not be impacted. So how this multiple join works? So when you give from employees and then join table 1, then join table 2, so Snowflake goes in an order by like this. This table D2 table will be joined with the D1 first, and whatever result comes out, that will be joined with this table. So that's how it is executing. Okay, so let me give you the result. So this result gives me 2 times ID name because I have tried to join the same table. But if you see the query history, not query history, but let me give you the query profile for that, and you will see what I am trying to explain. Okay, so as you can see here, so this is department, and it is trying to join d1.id is equal to d2.id. Whatever result comes out as 4 records, and those 4 records are then joining with employees table. d2.id is equal to e.department id, and what we gave the condition is this one. We never gave the condition like d1.id is equal to d2.id, but it figures out how it wants to join, how it wants to calculate the results, and then you have to join with this 2 table, and then this table will be joined. So you make sure that to improve the performance, how we want to join them and how we want to make it efficient. Okay, so yeah, and there is another join is available as of join. So for that I am going to create separate video, a short one, because it is having a different kinds of data needed, like timestamp. So it works on timestamp columns only. So we will talk about it in the next video. Okay, and one more tip I would like to say, that whenever you are using some columns in the join condition, and if that join condition is used very frequently in multiple queries, then you try and see if that column can be used for clustering, if the data sets are very large. Okay, so that will improve your performance. So yeah, that's pretty much from this video. I hope you have understood all the joins and you might be able to use them in your project or any product. So yeah, that's it from this video. I hope you liked it. Please hit the like button and subscribe, because hitting like button will help me, and this video will grow, will reach to the larger audience, and that will help me also. So thank you very much, and see you soon in the next video.